Hello class, welcome to chapter 2, and this is continuation of chapter 2. We will start with measures of center, and this must be something you're familiar with. We have the mean, median, and mode. So let me quickly describe this, and we're going to look at ways to do this using the calculator. Mean is the way we say in statistics what is usually referred to as average. So the arithmetic mean is the appropriate term for this, but we see that average is used interchangeably. So there are some books that would call this the average. Well, the process is similar. We have, I'll just write here average. So it is the sum of all entries or data values divided by the total number of entries or data values. Okay, so we usually do that to find the average, the mean. Okay, then we have median. This is also known as the middle value. And to get the middle value, we need to have it arranged in the ascending order. Right? So we have to arrange data values in ascending order, which means lowest to the highest. And if you had odd number of data values, you will choose the middle one with no problem, right? One will stand out. But if you had even, then you take the mean of the middle two numbers. That will give you the median. Then we have the mode. Mode is basically the highest frequency. So if a number repeats the highest number of times, that becomes the mode. Very, very simple in terms of how we find mode. But you find its use a lot more in qualitative data, where say your data collects the eye color of all the participants in that particular group. And say you record colors, eye colors as blue, jade, brown, black, and so on. And say you had the highest number of times a color appeared was brown. Then you can kind of say that that's the mode because, or that's the center, meaning more people in that particular group, had brown eyes. So that was more to be generalized in that for that group, just because it appeared the most number of times. So we have mean, median, and mode. So let's take a look at an example and see how that could be done. Here we are given a list of 10 test scores, and we're asked to find the mean, median, and mode using a calculator. So let me begin by showing you how to do it manually, and then we can cross-check it on the calculator. Okay. So if we were to find the mean, the formula says we have to add all of these, 85 plus 94 plus 78 plus and so on, plus 62 plus 81, right? And we have 10 such entries, so divided by 10. So you're going to add all of these and get the answer. Now let's do the same thing using the calculator. Okay. Now you see that you have a list. So you want to start off by going into your stat. So I'm using the calculator. So let's start with stat button. Make sure you clear any previous entries. And then we go to edit, and which you will enter. And then, fill column 1, okay? So column L1 is where you will enter the values 85, 94, 78, and so on, okay? After that, you have a list now residing there. Now we need to go to the list function. So if you look at your stat button, you see the word list behind it in blue. So we're going to access that. In order to access that, we have to do the second and stat to get to the blue. So second button, And the Start button will give you the List button. So we go to the list, and there you see 3 tabs. You see the names, ops, and math. So use the right arrow button to take you to the math tab. When you click on the math tab, you see a menu, and you will go to number 3 in the menu, which says mean, and it opens parentheses. So make sure that you hit enter, and then it gives you a clear screen that says mean and open parentheses. So please enter L1 in it and close parentheses. You know how to enter L1. You do second and number 1 button. That gives you L1 because that's the blue entry there. And then hit enter. And you get an answer, right? So that's your mean. So you say the mean here is 81.6. As simple as that. Now you'd get the same answer if you did it manually with it that we did up here. It's just that you can see it's a little cumbersome. And if you missed out any one number or you mistyped the number, we're going to have a big trouble there because we wouldn't really know where we missed it. I mean, you have a similar risk in entering the list, but that is something we can do by going back to verify and see if the list is correctly entered. And after that, when you do the computation, you should be worry-free because you have checked your entries. Okay. Now let's talk about median. So to get your median, it's the same process. So we'll start with the the manual computation. So if it is median, what I have to do is I have to go back to my data set and actually arrange it in ascending order. So I'll try to do that right here so that I can keep it close to the list. Okay? So the smallest number is 62, 67, 78, and then we have two 81s, 81 and 81. Then there's 82 and 85, 91, 94, and 95. 1, 2, 4, 94. Let's quickly check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got all the 10 entries. So let me just pull that down here. 62, 67, 78, 81, 81, 82, 84, 85. All right, now because I have 10 entries, right? It's even number. So if you kind of see what the middle two values will be, you can kind of, walk your way to the middle. So you get these two values in the middle, right? So you want to take the mean of these two values. So 81 plus 82 over 2. So the median is found by taking the mean of these middle two values, which will be 81.5. Okay. Now let's go to the calculator. And it's the same process. You already have L1, right? So it's entered, L1 is entered already. So I'm going to ask you to go to second stat. If it's a fresh list, you have to enter the fresh list. Of course, you know that. But because we're using the same L1, you go to second stat, go across to math. And then this time you're going to choose the fourth menu, 4, which is for median. And it opens up like that. So hit enter, and then it gives you in a new screen, median, open parentheses. So enter L1 and close parentheses and hit enter. And that gives you the answer for median as 81.5, which is what we got. What it did for us was, because it's a calculator, it it kind of sorted it in the background and gave us the answer. It doesn't reveal that sorted version to us. It just gives us the answer. Okay. Now for median, we used a nice example where it was even. So it was odd, directly the value, the middle value there. So that's nice there. Let's go for mode. Mode is the highest number of times it repeats. Now, if you're doing it manually, I want you to go back to the median list and see what numbers repeat. So you can see that the 81 repeats. And that was it, right? 81 repeats, that's all. So then you go here and you say 81 repeats twice. Now, if you have two numbers that repeat twice or the same number of times, then you have two modes. Both of them will be considered as modes, and we call it bimodal. Okay, so you can have multimodal answers. If there was no number that repeated, then we'll say no mode. And so you can see how flimsy that is as a measure of center, just because it does not mean that there is no center. It just means that we couldn't find the highest frequency. Okay, so it's got its limitations. Now, how do we do this on a calculator? Again, it's easier if you have a smaller set to just do it manually. If you had a larger set, what we ask you to do is, you already have your list, isn't it? So what we're going to do is go to, let me write here calculator, go to stat, okay, and then go down to sort to the menu. So this is under edit, okay. So go down to menu number 2, which is sort A, open parentheses. Remember we did this when we wanted to sort, if you want to sort them, sort A stands for ascending order, sorting your numbers in the ascending order. So we'll be using this for other calculations. So you want to use this to arrange your numbers in ascending order. Let's go ahead and click on that. And then it opens into a fresh screen. And it says sort A and open parentheses. So go ahead and enter L1 and close parentheses. It's all to do with the list, the same list. So go ahead and enter that. When you hit enter, like previously you got the mean and the median giving you the answer. Here it'll simply say done. Why? Because it sorted the list, so you have to go to the list to see it. So go back to stat. And go to the edit, and there you see your list L1 displayed in ascending order. Now we did it manually, so we were able to arrange our median. For when we did the median manually, we arranged it in order, so we were able to see the 81s repeating. Now if we skip that step, if we did it using the calculator, we don't have that view. So this view kind of helps us. So if you go down your list, you can actually see what numbers repeat. So you see that 81 repeats, no other number repeats, and therefore you can say 81 is your mode. Okay. So this is something you have to do manually. The help you get from the calculator is to sort it for you so that any repeating numbers would be lined up right next to each other. All right. So that's your mean, median, and mode coming from your calculator. Next, we look at something called the 5-number summary. It's really important because it gives us the 5 most important details in your data set. So it's a descriptive statistic that describes the data to us through these 5 important numbers. Okay. So we have, so this is coming from your data. Your data is usually your sample, right? It's not usually the population because it's hard to go find details about every member of the population. So we go for the sample. So the first one is called as the sample minimum. Then we have the first quartile. Second quartile. I'll shortly explain what all these stand for. Third quartile, and the sample maximum. Okay. So sample minimum, let's go to that. These are in your data set, right? This is the lowest value in the data set. And sample maximum would be the highest value in the data set. So in between we have something called quartiles, right? So you have a clue right there. What this does is, if you take your data, your complete data set, and arrange it in order, so we call it the ordered data set. So in your ordered data set, if you could divide the entire data into quarters, into 4 parts, right? That is what we mean by the quartile. So when you divide them into quarters, we call them as Q1 for the first quartile. So this accounts for the first quarter, right? The first quarter, that's the 25th percent mark there. Second quartile is Q2. Second quartile will be the 50th percent, but this is right in the middle, isn't it? And we know that the middle value is nothing but the median, not the mean, but the median, because you arrange it in order. And this is all happening based on how only after the data was arranged in order. Without the arrangement, you can't really divide it into 4 quarters, because then you can't say anything about the median. We can't really say that's the middle value if you didn't arrange it. So that's really crucial. All right. And then we have the third quartile, Q3, and this would be the 75th part of your data. Okay. So that's where you have 75% of the data below it, and you have 25% of data above it, which will form the fourth quarter. Okay. So this is how we, and these details are really important to us. Now, there are ways in which we will organize this. We can get this from the calculator. We can also get this using a special graph called, whiskers, box and whisker plot. Okay. So let's first start off with the values itself. Okay. So maybe I'll give you a problem here. Okay. We'll write the problem this time. Find the 5-number summary for, and here's the data, 3, 5, 7, 9, 11, 12, 14, 16, and 19. Okay, this is kind of easy in a sense. So all you have to do is go ahead and use these data values to get the 5-number summary. Okay. Now, if you look at it manually, right? Manually, well, it's a little boring for the fact that this is already arranged for us, so it's less work in that sense. If it's not arranged, then you'll have to arrange it. Well, it's arranged for us, so you know already the sample minimum is 3 and the sample maximum is 19. And because it's arranged in order, you can find the middle value and then the first quartile and the third quartile, right? So in this case, the median is, there's a different color here. The median is 11 here. And, the first quartile is the 25th percent, right? That is basically, now this, let me just write here. This is your median, which is the 50% mark, right? That's your Q2. So your Q1 is half of this data value, right? So it's half of the left of median. So you basically want to go ahead and see what the left value would be. So then if you were, let me use a different color here. So between 3 and 11. So it's as if your data set is between 3 and 11. That's not a good color because it doesn't differentiate it for us. Okay, here. So then this is going to get a little messy, but I'm trying to walk to the middle value here, right? And that middle value appears to be 7, right? But then if you are using the median, then you are looking at you're including the median value as well. So we can't do that. So we have to actually look at, hold on, just these values. And if you walked towards the center, you have the middle two values. So you have to take the average or the mean of 5 and 7, and that comes out as 6. Okay. And likewise, if you looked at the other end, right, this will be the 3/4 mark, right? The Q3 is the 3/4 mark or the 75th mark. But if you look at it, this is half of the right of the median. So once again, you walk to the middle and you have these two. So Q3 is 15, right? You take the middle value of these two. Now let's see if we can use the calculator to do this for us. Okay. So now go ahead and clear your L1 and enter this in your L1 column. Okay. So I'm sorry that the numbers are a little cluttered there, but I hope you can still see through the numbers and you were able to enter in your list. So I presume this is what you did. You went to Stat, Edit, and then you did column L1, right? All right. Now, you could do it individually. If you recall, we did second Stat and went to that list, went across to the math and went down to mean, median. But remember, we didn't want the mean here. We don't want the mode here. So that option wouldn't work. In fact, we have a better option. So this time, you will now go to Stat. Once you've entered your list, go to Stat. And then you have the tab on the top, right? You have the Edit. We've always been using the Edit. Now you have 3 tabs, Edit, Calc, and Tests. I want you to go to the middle tab or the second tab, which says Calc. And you have the menu there. Go to the first menu. It's already on the first menu. So it's enough that you hit enter. But the first menu is 1 var stats. Okay. That means one variance. Variable, sorry, one variable. So you have 1 var stats. So hit enter. You have a lot, and then you have a list in my version. Right? You have list. So enter there as L1. Okay. Again, L1 is entered by using second and the first button. Then you have the frequency list. Hit enter again. It takes you to the frequency list. Leave it blank. Then you see the word calculate. It's now highlighting on that. It blinks on calculate. Hit enter again. And then you have a list of values, right? You have this X bar, summation X, and so on. Ignore all of those. You have, in fact, the screen ends with this n equals 9. Now that is important because n equals 9 tells me that there were 9 entries. So that means I did enter them correctly. And you see that it has an arrow, down arrow button there, which means it's asking you to go further down. So use that down arrow button. And if you click on it, you have your 5-number summary looking at you beautifully there. So you have the min X, which is the sample minimum. It shows it to be 3. Then it says Q1 as 6. MED, median, is 11. Q3 is 15. And max X, maximum X value, or the sample maximum, is 19. So we got our 5-number summary beautifully here with additional information on the N to verify if we entered all our numbers correctly. And as always, try to check when you enter your list, because once you do that, then all these numbers would line up nicely. You'll get the correct answer. So you got your 5-number summary coming to you very quickly in using your calc button in your stat. Okay? 1 var stats. I hope that was fun. All right. Say you had a frequency table given to you like this, and they ask you to find the 5-number summary. It's not a list. The list is, it's not raw data. The data has been organized as values and frequency. Well, here too, you can kind of work around this by simply listing the number of times you see it. So it says 1 has the frequency 3. That means 1 repeats 3 times. So just write 1 3 times. 3 also has a frequency of 3, which means 3 repeats 3 times. 4 repeats only once, 6 is only once, 7 is once, 8 is 4 times. Right? You can see that right across it. 9 is 3 times. 11 and 12 twice. Now enter this in your L1 and then go to stat, calc, 1-var stats, and then go down to, scroll down to see your 5-number summary. I'm not going to do that, but I just wanted to share this with you so you'll remember that if it came to you as a table, you can still expand it and bring it into the raw state by putting them in the number of times they repeat and enter it as a single list. We said quartiles divide your data set into quarters, right? So let's say this is the minimum value. That's the maximum value. It's arranged in order, right? So you want 4 parts, okay? 1, 2, 3. It should be equal, pardon me. So this will be Q1, this is Q2, and Q3, right? So you know Q1 is the 25th mark, right? 25%. I'll just write 25% here. That means you have 25% of the values of the data set occurring below this, and you have 75% of the rest of the data above it. Does it make sense? Okay. What about Q2? Q2 is that it's your median, but that's your 50%. So you have 50 on the left and 50 on the right. Okay. So it's equal. It's right in the middle. That's how you know it's in the middle, right? It's 50% this side and 50% that side. And what about Q3? Q3 is the 75% mark. That's the third quarter. So you have 75% of the data values occurring below it and 25% of data values occurring above it. Only 25% of the values happen after Q3. Right? So and that's how we understand. So 75%, if somebody is in the 75th percentile, it does not mean someone got 75% in a test score or something like that. That's not what it means. It means that the 75%, that 75% of test scores are the same or less than your score, and that only 25% of the scores are same or greater than your score, right? So that is what this means, 75% on a percentile here. Okay. Now, similarly, we have something called percentile. And you might get a hang of this because if quartiles means that they are broken into quarters, a percentile would mean that they are broken into percentages. Percentage means 100%, right? So your ordered data, so this is the minimum value, and this is the maximum value. Your data, this is usually used for very large data sets because you're going to break it down into 100 parts. So you have the data divided into 100 parts. So I'll say this is the first percentile P1, P2, P3, etc. So on. It goes all the way to the end of your data set, and then you have P99, and that will be P100. Okay. So you have your data now divided into 100 parts, and there you can have your P25, right, coinciding with the Q1, P50 coinciding with your Q2, and so on. P75 with your Q3 because that's the corresponding percentage on the percentile. It's very useful when comparing values. Usually, the doctor's office gives information, right? They say, oh, your child's growth is in the, let's say, 80th percentile. What that means is your child's growth is not 80% of something, right? It means that 80% of the scores of the growth scores are same or less than your child's score. Okay, so 80% is the same or less than your score, and 80% is the mark, right? So then above you there could be 20 or more could be the same as you, or the 20% of the scores are the same as you or greater than your growth score, your child's growth score. Now, we do have situations where we would be, you have the data, and then let's say, in this data, what would be the, say, 31st percentile, or what could be the 88th percentile? If you have questions like that, it's kind of hard, right, in your data to see which position would give you that. Therefore, we have a way, again, we have a formula that will help us do that. So I'll give you the formula and then describe what those spots mean. I equals K over 100 times N plus 1, okay, where I stands for the index or the position of a data value, because you're ordering it, right? So there will be a position. If I say that's the 5th position, then I will tell you if I equals 5, then it means we're talking about the 5th position of the data value. So index or the position of the data value. And then K is the actual, K is the percentile. So if they say, what is the 31st percentile, then K would simply be 31. N stands for the total number of data values. Right? Total number of entries. So total value. So we will, if your I, right, the I is a computational value based on this formula. So your I will not always be a round number, meaning an integer, right? So if your I is not an integer, then we'll have to round it up or round it down, right? In order to get to the next integer, you may either have to round it down or round it up. Because of that ambiguity, if you had such a situation, then we will take the positions for the rounded down and the rounded up version and take their mean. So I'll show you through an example what I mean by that. Listed are 20 ages for Academy Award winning Best Actors. What is the 50th percentile? Okay. The data is given to us. Now, for our convenience, it's already ordered, but let me write that because that's an important step to follow. Arrange data values in ascending order. Okay. So remember, this is what we call as the ordered data set. So when I say ordered data set, you know what I mean. I'm asking you to order it in the ascending order. Okay. So again, percentile is calculated for an ordered data set because we're talking about the position of a particular data value. Okay. So now let's, that's step 1. Step 2 is to get the formula values to go ahead and plug them in. So we are trying to find the position for that corresponds to the 50th percentile. Here, 50th percentile is the median, so it's the middle position, which is fine. We are just trying to show you using something that's simple to get to this. And I'll show you in another problem a different percentile that's not as easy to obtain. So let's locate our values. Now, because it said it's the 50th percentile in the problem, right? That is your K, because your K stands for the percentile. So K is 50, okay? And N is the total number of data values. So we're already given that there are 20 ages, listed are 20 ages of the best actors. But you can also go back and count them if you wanted to make sure that there are 20. So N is 20. So we have K and we have N. If we can find I, that will give us a position, and that position will tell us which value in your data set it corresponds to. So let's go ahead and compute it. I is 50 over 100 times 20 plus 1. Okay. So that's actually 50 over 100 times 21. So it's basically 21 over 2, right? 21 over 2 would be 10.5. So we want our I to be an integer. So I is not an integer. This is important because remember, I corresponds to the position. So if it's 10.5, how do you know which one is the 10.5 fifth position? If I say the third position, you know I'm talking about 22. If I say the fifth position, you know it's 26. If I is 3, then I know it's the third position. If I is 5, I know it's the fifth position. So how can I locate when I is 10.5? And this is where we have a dilemma, right? You can round up or round down, isn't it? So when we round it up, it'll be the 11th position. When we round it down, that'll be the 10th position. So we are told to go ahead and locate the 10th and the 11th position, which happens to be 36 and 33 and 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10th position and this is the 11th position. So they want us to find the mean of the two values. So I'll just say 11th position was 36, the 10th position was 33. So to get your I value, you are looking for, your I value is obtained. It's 10.5, but to get the mean of 36 and 33, you get 36 plus 33 divided by 2, which gives you 34.5. So how do you interpret this? So you come back and say, well, we'll go back to the question. It said, what is the 50th percentile? So we say the 50th percentile I'll just write it in words. The 50th percentile is 34.5 years. Okay. What this means is, again, we have 50% of these actors whose ages are 34.5 or below, and we have 50% of these actors whose ages are 34.5 years or above, because you're right in the middle there, right? So it's 50% here, so that's the middle value typically. We'll take a look at another list and see how we can find the percentile, the value. Now in our next problem, we have the same scenario, but this time we have 29 in the list. Okay, the 29 ages of Academy Award winning best actors. And what is the 70th percentile? Interesting. So 29 and 70th percentile. So as always, look for ordered data set. It comes to us in the ordered form, so good for us. And we're looking for the position. So let's write the formula. K over 100 times n plus 1. And then let's collect we're trying to find I. So K will be the 70th percentile. So K is 70. N, we're told there are 29 ages. You can also count how many entries we have. That's 29. Now we can plug those in. 70 over 100, 29 plus 1. Okay. So do the computation, and that comes out to be 21. Okay. You can do it here on the other side. So that's going to... All right, so I is 21. No ambiguity here. You got an integer. So I is an integer. That solves the problem for us because we can count this, right? So I can go to the 21st position. So if you, of course, you count from left to right, isn't it? So go for the 21st position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 position lands on 66. Okay. So then you come down and say the 70th percentile is 66 years. Again, how do you interpret this? Again, think of the minimum age, maximum age, or the years, right? And let's say 70th percentile is here. The way we denote it is P70, like that. Okay, that's 66 years. So if it's a 70th percentile, what we're saying is 70% of those actors have an age that is either 66 or below, right? And 30% of the actors are of the age 66 or above, right? If you even look at your data set, you can begin to see that, right? Because majority of them are younger, and so they are in the below the 66-year mark, and the 30% mark would apply for those who are 66 years of age or above. Okay. And then we have something called interquartile range. It sounds grand, right? It's like intergalactic stuff. This is interquartile range. We in fact call it the IQR, interquartile range, and that is Q3 minus Q1. Yeah. So if you got the third quartile minus the first quartile, that difference gives you the IQR. We will find this more useful when we get to the box and whiskers plots. Okay, so let's get to that. Box and whisker plot. So roughly speaking, if you were to draw a number line, right? Let's say it has to be positive. You're only looking at the positive side of it. I'll just mark up to H because there's no room there. Okay. So it's going to look like this. As the name says, there will be a box and whisker. So let's say your oops. So much for touch screen. Let me draw the box and kind of show you. It's just a rough box. I'm not even giving you the data, so don't worry too much. Oh. Okay. So what happens here is your box and whisker plot looks like this. Okay, it's like you have the box in the middle, and then you have those two lines by the side that look like whisker. Okay, that's the reason why it's called that. Well, what it does is it basically gives you the 5-number summary. Okay, so this will be your sample minimum, and this would be your Q1. This would be in the middle, so that's Q2, Q3, and that's the sample max. So you can do this manually and plot them, but we're going to do this using the calculator. Okay, so I'll come back with a data set now. So I'm going to call upon our 5-number summary data, right? We use that example. Bear with me. So if you recall, we did this problem for the 5-number summary, right? And it is related to your box and whisker plot. So because this, I hope you did the problem with me on your calculator, and I hope that this is there in your list already. If it's not, of course, go ahead and punch those in. So we have the list already, and now we're going to construct a box and whisker plot. So for that, you have to go to second Y2, okay? So we say second y, I keep saying y2, it's y equals. Okay, y equals, that takes you to the stat plot. And for all graphs, this is where we go, isn't it? You're now familiar with this. So we go to plot 1, and then, of course, it's turned on, so just make sure it's turned on. And we go to the type. And you have 6 graphs in that, right? So the first row has 3 and the second row has 3. So please go to the second row and choose the middle one. Second row, middle graph. So if you are counting, then it'd be like the 5th graph, right? Out of the 6, that's the 5th one. Okay, and then for your X list, this is this data is available in L1. So enter L1 there if it's not already there. And frequency is 1, leave it as it is. All right, and now it's time for us to go to Zoom. You know the drill, right? Zoom, ZoomStat. ZoomStat is the number 9 there, you know that. And you see the graph right away. If you don't, then click on the graph. But ZoomStat again gives it to you to fit it in your graph. Now we have 3 stat plots, right? 3 options: plot 1, plot 2, plot 3. So because of that, if you wanted to compare 3 things, the whole idea of 5-number summary or box and whisker is to compare. So usually, there are 3 data sets that are compared. And so the space here, you see that this one appears right on top. You cannot adjust it to make it go lower, because typically if you had entered values in plot number 2, plot number 3, all 3 will appear one below the other, the topmost being plot 1. That's the reason why it's sitting way above. Okay. So if you go to trace, but at least your graph looks like this, right? Let me graph that. Okay. And I will mark the positions there. So if you go to trace, the leftmost, this one is pointing to a 3. It says min x equals 3. Remember, min x came from your 5-number summary. Then move your cursor using the right arrow, and that lands you in Q1. It in fact says Q1 is 6. Then again move the button, you get Q2. In fact, it says median, MED. $11. It got a little crowded, so I had to move it a little bit. Then move to the next one, Q3 is 15. And then move one more. There's 5-number summaries, so you expect 5 of these. That will be max x to be 19. You can go back and verify that these were the very numbers we got. Manually, we got it through the stat, calc, 1var stats, that button. And we also got the same thing using a visual view of it from the box and whisker plot. When we try to describe our data, we have used the measures of center very much. So we also have measures of spread. How spread is the data? How far does it deviate from the center, from the middle? And so for those calculations, we use the concept of variance and standard deviation, and a little extension of it is z-scores. You're just going to get a gist of it and how to use the calculator to compute these ones, because the formula themselves would be really complicated if we were to do it by hand. The whole idea of standard deviation or variance is to measure the spread of the data. Okay, so if you had a bar graph or a histogram, and if you kind of connected it, or technically speaking, if you're looking at a bell curve, remember we spoke about how I'm just drawing something, okay? So if your histogram looks something like this, we try to see if we can trace some kind of a bell shape. Okay, so if we can trace a bell shape, then we know it follows a normal distribution. So we are really interested in seeing what that shape is. And ultimately, when you are looking at the distribution, it helps you to see the spread. Okay, so this looks more spread out. So I just want to focus on just the bell shape, not the bars. So let me show it to you here. So if my graph has a rough shape like this versus another graph that has a shape like this, you can see that the blue graph is narrow and taller, whereas the pink graph is wider and flatter. So if it is narrow, you know that the blue graph has less spread, which is a good thing. If there is less spread, it means that it doesn't vary too much from the center. Okay, so that means the standard deviation is small. That means it's desirable. Okay, I just put the tick mark there to show that it's desirable. On the other hand, if it is like pink, we see that it's spread little more, so the standard deviation is going to be higher, and it just indicates that that there is more spread in the data. The data is spread out from the center. How do I know what the center is? Well, the center is always the peak. So the peak of your graph is where the center is, and therefore, if your graph is, if your shape is, hugging that center, if it's staying closer to that center, then you know your data is not spread out much, which means it's a lot more reliable. It's closer to the center. Whereas when it's spread out much, it means that you have more variability. More variability means less reliability. Okay, so I'll just write that here. Okay. And now this table gives you actually the formula that is involved in measuring or calculating the standard deviation. Now, standard deviation variance, what are they? Well, standard deviation variance are connected such that variance is the square of the standard deviation. So say you got standard deviation to be a value of 2, then the variance would be 4. 2 squared is 4. If the standard deviation was 3, it would be 3 squared, which is 9. I mean, standard deviation would generally be a decimal value, and so you'll have to square it even if it's a decimal value. As you can see, the standard deviation has the formula that involves a square root, so you can expect decimal answers there. And for standard deviation, the shortcut in English would be SD, but that's not a symbol. It's just a shortcut to write standard deviation. But the symbol for that would be in 2 forms. Now, if you are talking about the sample, which is usually your data set, you will use the lowercase s. If you are using a population, usually it's very hard to find this, but in some cases, yes, it's possible. When I say some cases, what comes to my mind is, say, they're trying to study about a particular rare disease, and say there were only 1,000 people in the entire world who were affected. For that moment, that 1,000 is the population, because that's all of them who were affected. It is ones that were recorded and that were known, right? So that 1,000 is the population for that study, and so if they have the ability, if they have the funding and other resources, yes, they can go after all those 1,000 cases and draw that information, in which case they'll be able to find the standard deviation for that population. Now, if they cannot do that, then they will resort to a sample, and therefore they will take a sub-collection. So probably they will be able to reach out or collect data from 50 people out of the 1,000, right? So that becomes your sample. So to define the difference between the sample for a sample and the population standard deviation, we use different letters. So standard deviation for sample will be S, and the standard deviation for the population will be this letter called sigma. Okay. Now remember, we also have another sigma, which is the summation that you see there, and we use the word summation instead to define it. The mean, we have been easily finding the mean all along, but remember again, if you can find all the values for your population, you can definitely find the mean of your population. If you don't have access to the entire population values, then you'll go for a sample. So here again, we have a symbol. So for sample, the mean has a symbol X bar, X with a little line on top. And if we are talking about the mean of a population, then we use a Greek letter called mu, M-U. And as you can see, we assign Greek letters for the population and we assign English letters for the sample. What I want you to understand is, right now, we are not using the data from the entire population. We're looking at the sample. But when we get to inferential statistics, the second half of this course, there we will be trying to make projections about the population, because that is unknown. So we use these parameters. The parameters are measures of the population. Statistic would be the measure of the sample. So we use parameters like mu and sigma to determine what they could be, what the population mean could be, what the population proportion could be, and all those things we will do using the sample. So we'll use the sample to project information on the population. So we will use them later on. We do have formula that involves this. And so if we talk about the sample size is how many entries there are in your data. Okay. If your sample size, okay, we should technically say size, but we just call it sample size. It's a small n if it is coming from a sample, and it'll be a capital N if it's coming from a population. Here we're not giving a Greek letter. Well, I think there is a capital N looking letter in Greek. So we have a small n and capital N to distinguish between the sample and the population. So I'm going to remove the word size, sample, and just call it size, so that, it's not redundant that for the sample, it'll be sample size. But if it's a population, it can't be called sample size, right? All right. So population size will be a capital N. And so you can see the complex formula here. We're going to use technology to help us calculate the standard deviation and the variance and learn how to interpret it. A student of statistics bought various movies and wondered about the statistical properties of the movies. The student converted all the movie lengths to seconds, and the data have been reproduced below. So this is a collection of movie lengths in seconds. I'd like you to go ahead and enter this in L1 in your calculator. Okay. So you could pause the video here and enter it. When you're done entering it, this is what you'll do. We'll go to Stat. So let's say after entering data in L1, you go to Stat, and then go across to Calc tab, and there you will click on the first one. So hit enter. Basically it's 1 var stats. And then if you then it takes you to the list, right? List. So mark it as L1. Then hit enter after that. It takes you to the frequency list. It's empty. That's okay. Hit enter again. It takes you to calculate. Hit enter. It blinks at calculate, then hit enter. And it takes you to 1 var stats. This is familiar to you because we use this to get the 5-number summary, right? So we're going to use this now to get our sample standard deviation and sample variance. Okay. Now this is a sample, right? This is not all the movie lengths. So this is a sample, and so we are going to use ones related to the sample. So you have plenty of information there. Okay. So you have X bar, which is given to be 6197.5. You know that X bar is actually your sample mean. If you added all of these numbers and divided it by 1, 2, 3, 4, 5, 6, 7, 8. If you divide it by 8, you get this. Oh, by the way, you have n equals 8, so there were 8 of them. Okay, that's there in your table, in your calculator. Then I'll just describe what each one stands for, although these are not what we need right away. You see that E-like thing is an X. We call this this is also known as sigma, but we're going to call it the summation symbol. Summation means you added them up. So summation X gives us 49580. What this means is it adds all data values. Okay. There are times when we have X and Y values, two sets. So that's why it keeps saying X. But here we have just one list. So that's our data value. And so we just list them all. Okay. So this is the sum of all those data values. The next one is summation X squared, which is 327856400. It's a long number because these are big numbers already to begin with. Summation X squared. So summation, you're adding what? This is adding X squared values. So that means you do the 5400, you square this one, square 4400, take the square of that. Like that, you're going to take the square of each of these X values. That's what X squared means. You're going to take the square of each of these values and add them up. That's, you're adding them up because of the summation symbol. That's what this means. So you can again look at it look at the size of that number, the huge value you get. And that indicates that's coming from having squared them and then added them all up. Then you have something called SX. And that comes out as 1714.824023. Yeah. This technically, it means sample standard deviation. Okay. And you have the other one, right? It has a sigma X. 1604.070993. So the symbol wise, it technically means it's the population standard deviation. Now there is a trick here. Now you have to remember that the calculator accepts what you enter in it, right? So if you have entered only 8 values, for it cannot distinguish whether it is a sample or a population because we haven't indicated it anywhere. So it provides both these answers. Now, I'd like you to look at this formula for a bit. You notice that your standard deviation has 1 over n minus 1, so it takes 1 less than the sample. So if your n is 8 in this case, in the calculation, it will do 1 over 7 because it's n minus 1. Whereas if it is doing the population, it keeps the n as it is, the capital N is as it is, right? So that is our challenge here. What happens is the calculator does n minus 1 here. Here it keeps the n fully. And we want it to keep the n fully because we want it to include all the values, right? Therefore, we are going to use this information as our sample standard deviation because the calculator does not know the difference. At this point, it's giving you both these values. So we're going to do the sigma X. So according to this problem, this will be our sample standard deviation. Okay. Now, if your homework problems direct you otherwise, because it's just a question of which one you choose based on the instruction and based on the data set. Now, if it is your own research, that's different. You will know what to do. But if it is a problem given to you where we need additional directions, then go by those to decide if they wanted you to use the SX or the sigma X in your homework problem. So look at the instruction there. Okay. So here your sample standard deviation actually will be 1604.070993, which is approximately 1604.07. Okay. And then the sample variance is this value that needs to be squared. Okay. There are two ways to get this value. you can actually type this number. You can exit the screen. You know how to exit. You can do the second and the mode to exit. Okay, that's the quit button. Okay. To exit the current screen, you're going to do second, and the button right next to it is the mode button. Okay, together it means to quit that screen. So you can do that, exit out, and you get a blank screen. There you can punch these numbers 1604 point, etc., and then use the square button, x squared button, to get the square of it. That's one way to do it. There's also another way to do it, which can be done by clicking on the vars button. Okay, to get the sample variance, you can click on the vars button. Okay, I can do that, and then go down to the menu number 5, which there are 2 tabs, right? So stay in the vars tab. So when you click the vars button, there are 2 tabs. One is called the vars, the other one is y vars. So stay on vars, and in that, go down to the menu number 5, which says statistics. This is really neat because you have, each one of them individually available to you. So if you wanted just the n, then you can just hit on the n and it gives you what the n is. So it specifically gives you these values. Here we want to square this value, right? So you want to go down to menu number 4. Oh, then I'm sorry. The 5 tabs, statistics, actually gives you a host of tabs. You have the XY tab, Sigma tab, EQ tab. So stay on the XY tab and go down to menu number 4, which says Sigma X. Hit that, and then use the X squared button. Then it's the X squared button. Okay, so that's the button below, two buttons below math button. Anyway, try to figure where it is. Okay, and then hit enter, and that gives you 2573043.75. Okay, so that is your value. This is rounded to 2 decimal places. Again, in your homework, please be cautious about which one they want you to use for the standard deviation. They want you to use the SX every time, or did they want you to use sigma X every time, even though it was for the sample. So you really want to distinguish that particular part. And of course, figure out how many decimal places to round, because as you can see, these will give you a number of non-terminating decimal numbers. So learn to round them appropriately. The last concept in this lecture would be z-scores. Again, this is a preliminary introduction to it, so you'll understand this better when we get to use them in inferential statistics. So for now, I will just try to show you how to compute them. Okay. So z-scores is a way of measuring a data entry on a different scale. You have x-axis, right? That's an x scale. So z-scores are using a different scale. Think of measuring temperature, right? You can measure temperature in Fahrenheit, which is one scale. You can equivalently measure temperature on another scale called the Celsius scale. So you have the same temperature, but the numbers will look all different, and the interpretation will be different just because of the scale in which it's measured, right? So we have Fahrenheit and Celsius. Similarly, we have x-axis, which gives you the x values, and then we have the z-scores, which come from the z-scale. So a z-scale is typically used to standardize data. Again, more details on that will come to you when we look at it in context. Right now, we'll just learn how to get this value. The way we get this is we do x minus x bar over s if you're using old sample data, right? Because x bar is sample mean, s is sample standard deviation. The same formula is adjusted if you have your population information given to you. So if you have the population data, then you will use this. You can, of course, compute this manually because it's pretty simple, the calculation, but we can find a way to compare values from different data sets. For that, you'll find calculator very helpful, because to get the z values for two different data sets would be cumbersome if you were to do it manually. So I'll present a problem here. Remember, I said we are going to compare two data sets, and therefore, even though the z-score calculation itself is simple, you have S and X bar, those are heavy calculations involved in it, and that's the reason we're going to use the calculator. So let's read this question. Two football teams scored the following provided in the data set. When the two teams met on the 10th week, Team A scored 14 points and Team B scored 35 points. Treat the given data set as examples. Which score was more unusual? Use a calculator to calculate the z-scores. Okay, so they gave us the data sets, but then they also told us about one specific week. Okay, when the two teams met on the 10th week, Team A scored 14 points and Team B scored 35 points. Ooh. So what we have, though, is the scores from Team A and Team B. So we really don't know which week we're talking about. So let's first take a grip of the data first. So go in and clear your data sets, lists 1 and 2, because you need two columns to enter your data. So go ahead and enter your data in list 1 and list 2. Just a quick recap. Stat. Of course, clear data. For this one, I'm just going to give you that information too, because we saw it in a couple of videos before. So go to Stat, and in the Edit tab, go to 4, Clear List, it says. Then go to that fourth one and hit Enter, and then it says, it takes you to a clean window, and then it says Clear List, and then it blinks next to it. Where it blinks, you have to enter L1. Again, for L1, you do second and 1. All right, when you're done with that, then it says Done. Then go back to Start. And do the same thing to clear your second list. Okay. Go to number 4, the fourth item in the menu. So that's going to say clear list, and this time you're going to enter L2. L2 is the second button and the number 2 button. So that's L2, and then when it's done, now that's cleared, you will go back to Stat, and then go to Edit, and there it's the first menu which says Edit. And that's where you will enter columns L1 and L2 for Team A and Team B from here. Okay, so it's a good idea to pause the video at this point and enter the values. Now we have two data sets, right? L1 is your Team 1. So to get information on Team 1, we want to go to Stat, Calc, that's the tab, and in that you go to 1 bar Stats. Okay, and that's going to give you details for the first one, the first team. So here you have X bar, which is the sample mean, which gives you 24.2. And then you have sample standard deviation. Now again, for variation here, I'm using SX as it is. And they want us to round to 3 decimal places. So let's do that. That's 9.102. So always remember that, depending on the problem and the context, you may have to switch between the two. But from my experience, we typically use SX as it is, with the understanding that that's the sample we have provided. But sometimes when you enter the entire population, rarely, you can compute your sigma x as well. Okay, so here we are using the SX as the sample standard deviation. So that's nice that we get to see that too. Then for list L2, which is your team B, I wrote it as A, 1 there, it's team A. Do the same thing because you now have calc 1 var. Oh, I forgot to mention an important stuff here. Let me backtrack a little bit and take you to team A. So when you did the 1 var stats, you had the list, right? That's crucial. A list, it has to be selected to be L1. So type in L1 to get the list there for team A. And here you have to go to list and then change it to L2. So clear the list and then hit second and number 2 to get L2 and then calculate. And this will give you, because it's still going to show you X bar and all these things, but you really have to know for which list it gave us that information. So X bar here comes out to be 18.4 and SX would be 16.568 upon rounding. Okay, so this is really, really nice that we have these two details. So this is for team A and this is for team B. So I'm going to kind of compare them here. And we know that Z is X minus X bar over S, right? Same formula here. If you are looking at the symbols that we got from the calculator, it was this is SX and this had SX. That was the only difference, right? But the formula is the same. So now we have to calculate for the first one. Okay. For that, I have to go back to the question because we have X bar and we have SX, right? From the calculator. What is X? So let's go to team A. So in the 10th week, team A scored 14 points. So your X here is 14 points because that is the specific value they've given us. And for team B, it will be 35 points. Okay? They said treat these as samples, right, in the problem. So that's why we're using SX here. Now let's go ahead and plug the value here. So that will be 14 minus X bar was, let's go back here, 24.2 divided by 9.108. I'm sorry, 102. Okay, compute that. I'll also parallelly write for team B, X was 35. 35 minus 18.4 divided by 16.568. Okay. Now, plug these in your calculator. This is something you have to do manually. Calculate it, but you can use a calculator to punch these in and then write down the results. I get these two values. Team A is negative 1.21, 121, and B is 1.002. Now let's go back to the question, and it says, which score was more unusual? Okay. Well, again, you're just doing a quick comparison here. And to compare them, you want to take the absolute value. So if you take the absolute value, it returns a positive answer for this one, right? Versus 1.002. So this one is greater Okay, I'll just put the symbol here, okay? Greater, that's better. So 1.121 is greater than 1.002, and therefore it is unusual for team A to score 14 points than it is for team B to score 35 points. Okay. So you'll see that this kind of comparison helps in test scores and things like that to see if there was any unusual pattern that was exhibited and things like that. All right. So, well, we have come to the end of this chapter and this lecture, and see you in the next one.